Okay. So, we're going to go through the guided practice. I'm going to run through a couple things. We'll do our normal thing here. Run through the guided practice, address some questions. Please pay attention. And as soon as Ian's back. And then we'll break. We'll do some independent work. We'll come back together and we'll go over everything. Okay? So, everybody should be following along. You should have April 19th open here. The guided practice should look just like this here. You'll notice that you've got guided practice we'll go through. There's your independent practice. And then you guys are going to do the back page of the independent practice and the homework and practice as well. Okay? Just the first page of homework and practice. Again, these are the pages from inside your workbook, but I do it this way because it's a little bit easier. I can look back on it then when you turn your packets in, and also it's easier to pull up on here. So, let's go through the guided practice really quickly, guys. Hey! Focus, guys. Everybody's all over the place. Yeah. This isn't bad. You guys have done this stuff before, so let's look at it. Go ahead. We are going to do, we're comparing fractions, but we're using number lines. Okay, but you guys remember this. We've done this before. So it should be kind of review. I know some of you guys don't like number lines. Some of you do, though. And if you look at them, you can look at them as you do, say, fraction bars. Okay? Kind of similar. So, it says right here, when two fractions refer to the same whole, what do you notice when the denominators you are comparing are the same? So look at it again. Guys, everybody should be following along on their paper. Okay? Remember what I said. I'm not joking. I'm going to say this, and I've been saying it all year. Circle, highlight, underline the important information. Make sure you can look back at it. I mean, even if I'm reading a problem to you, you need to be reading it as well. Okay? And reading the instructions. Okay, guys? So listen. When two fractions refer to the same whole, what do I mean when I'm saying that? What does that mean? What does it mean? Test it.
The same denominator.
It should have the same denominator. That's exactly right.
All I should be up in.
Because it says right there that the denominators are the same. Now, same whole doesn't necessarily mean that it's going to have the same denominator. But in this case, Heston's right, though, because it says the denominators are the same. You could have the same whole without having the same denominator, can't you? Think about it. What if I drew out two pizzas? Yep, we're talking about pizza again. And I said to you the pizzas were the exact same size. They would be the same whole, correct? Or if we drew out fraction bars, and they were the exact same length, they would be the same whole, correct? Or if we did number lines, both from 0 to 1, and I told you those are the exact same length, those would be the same whole, correct? Yes, guys? Yes or no? Wait, what? I can't hear you. Would they be the same whole? Yes. So these could all be the same whole, right? You can look at it in a bunch of different ways. But now it says, when two fractions refer to the same whole, what do you notice when the denominators you are comparing are the same? What does it mean when the denominators are the same? Ian. What does it mean when the denominators are the same? You have two fractions that you're comparing. Remember, guys, we've compared a lot of different types of fractions. What happens? What does it mean when we have two fractions that have the same denominator? What does it mean?
Well, very clearly, the numerator is different from the other one.
It could be, but it doesn't say that. It could be the same. What if I have, okay, so we've already addressed that these are the same, right? So let's say I've got two pizzas that are same. I cut them both in half. They have the same denominator, but they also have the same numerator. In this case. But the question doesn't actually mention numerators. It only mentions denominators. So when it says when you have two fractions referring to the same whole, what do you notice when the denominators are the same? Do we need to take a step back here, guys? What's the denominator? Jack?
The number in the bottom.
Which number?
The one that shows you how many pieces.
That's right. The denominator shows you how many pieces you cut the whole into, right? That's how many pieces you have total in the whole. And it is also the which number in the fraction? Which number in the fraction? Wait, what's that again, everybody? I couldn't hear everybody.
The bottom number.
It's the bottom number. So in this case, this is our denominator, right? The 2, because we've cut it into, each one of these is cut into 2 parts. So what if you're comparing fractions where the denominators are the same? What does that mean? They've got the same whole and the same denominator. What does it mean? What does it mean? Andrew? Well, yeah, it does mean, it means that they've got equal numbers of what? Equal numbers of what? If the denominator is the same, it's the equal numbers of what? What do we think? Ariana? Yeah, that's right. We've got equal numbers of parts, right? So if you have, look at these two. The denominator is the same. And the reason I put 1/2 and 1/2 is because this would be 1/2, this would be 1/2, this would be 1/2, and this would be 1/2. But the important part is, even if those ones weren't there, your denominator is the same, which means that both parts, both wholes, are cut into the same number of parts, correct? Isn't that what that means when you have denominators that are the same? You've got the same number of parts. So we would say the same thing over here, right? What if I cut these into thirds? Do both those shapes have the same denominator? Jack? Yes, they do. And what would the denominator be here? What is it? Yes, that's right. Now we don't know what the numerator is because we haven't talked about what we're representing. And remember, the numerator is what you represent, right? So it's what you're shading or what you're taking away. Remember that? So if I did this, they still have the same denominator, but they're going to have different numerators, aren't they? What's the numerator for the top one? What's the numerator for the top one, Heston? That's right. That would be 1/3 because we shaded in 1. What's the numerator for the bottom one? Schmidt? 2. So they have the same denominator because they have the same number of parts, but they have different numerators because we're representing different parts, different numbers of parts from within the whole, correct? Does that make sense, guys? You remember this. This is review, right? Thumbs up if it makes sense. Was the wording confusing? What do you guys think? A little bit? Grace? You weren't here for when we did this stuff, comparing? We've been comparing for weeks.
No.
Oh. You mean you weren't here when we read the problem. So it said when two fractions refer to the same whole, what do you notice when the denominators you're comparing are the same? Is that confusing when it's phrased like that? Does it make sense? You know what they're asking? Kinda? All they're asking you really is, what does it mean when the denominators are the same with the fractions that you're comparing? And what does it mean? What does it mean, guys? Who wants to tell me? What does it mean? Come on, I'm going to call somebody out. Bruce? What does it mean when the denominators of the fractions you're comparing are the same? Well, the wholes are the same because we talked about it in this, and it says it, right? You have the same whole, same denominator in this case. What does it mean? What does it tell you? If you have two fractions with the same denominator, what does it tell you? Andrew? Say it again. Like denominators, exactly, which we've already determined are the easier ones to compare, right? And why is it easier? Why are like denominators easier to compare? Andrew? That's true. You're right about that. But what does the denominator tell us, Schmidt? What does it tell us again?
It tells us what we're like. What's the? I know what it means, but the bottom number and the fraction.
It is the bottom number of the fraction. Briggs, what does it mean?
How many parts we're representing?
How many parts that we're representing would be the numerator, right? Because that's the part that's shaded. I get where you're going. The denominator, guys, remember this. The denominator is how many parts are in your whole total. How many parts are in your whole total? The numerator is how many parts you're representing, like how many you're shading or how many you're taking away, right? But the denominator is your total number of parts. Total number of parts, remember? So when you get a shape and it's cut up and you count it, all the parts in the shape, that's your denominator. The numerator would be the parts that are shaded or taken away, right? It's the parts out of the denominator, which I think is what Briggs was saying. That's right.
We did exercise about.
Well, you guys feeling that? We just played Kahoot. We did some geometry. Well, apparently not. Guys, you don't have a long until recess. Okay. Okay, everybody stand up. Class. Please go back to your desk quickly and quietly. Why do I hear talking? Please take a seat. Okay. Yeah. No, that's perfect.
Make sure we have this one.
That's perfect.
Okay, thank you.
Thank you. Okay. Now, let's go ahead and go back to what we were doing. What are we doing? Out of breath. I usually do push-ups with a mask on.
There better be all kinds of hands being raised when Dr. Weltman asks questions now.
Hey, you guys requested a quick exercise, right? Right. Please. And how are you going to do work when you got a jacket on top of your driving? There you go. Okay. Now, let's go back to this. You guys know this stuff. I'm telling you right now, you're killing it on the fractions part of the interim state test. You're doing it really well. So come on. Tell me what you know. You guys know this stuff. Okay. So, let's look at this one. It says, write a problem that compares two fractions with different numerators. So, please face this direction. Thank you. Write a problem that compares two fractions with different numerators. So when it says different numerators, guys, what does it mean? What does that mean, Allie?
Different ones that are shaded in.
That's right. So in the fraction, what number is different? If we have different numerators in the fraction, what number is different?
Oh.
Guys, what number is different?
The numerator.
Yes, but which number is that?
The problem.
That's right. Now, Allie's correct. The numerator is how many parts are represented, which usually means how many parts are shaded, right? How many parts are shaded or missing. So in this case, we're going to write a problem that compares two fractions with different numerators. What should our first fraction be? Somebody give me an example. Yeah.
3 out of 5.
Okay. Very fast. What's our second fraction going to be, Schmidt?
2 things, and it's one is the answer.
We don't know the answer yet. How are you going to give us an answer when we don't even have the second one there?
Okay, can I please get my clipboard so I can face this way? Because I heard one like this.
Where's your clipboard?
It's in my room.
Get it. Quickly. Give me a second fraction, guys. It's got to have a different numerator. Esther.
4/8.
That does have a different numerator, but, and it is true here, it doesn't specify the denominator. So we could do 4/8. Now in this case, if we did 4/8, what is 4/8 equivalent to? What's 4/8 equivalent to?
1/2.
That's right. So what we're really talking about is 1/2, right? So in this case, we have a different numerator and a different denominator. We could do it with the same denominator and different numerators, though, right? So we could have said something like 3/5 and 2/5, and that would have been easier. But let's take a look at this one. Just remember, these are equivalent. Which fraction is greater, 3/5 or 4/8? 3/5 or 4/8? Brewer?
4/8.
So let me ask you this. Remember that 4/8 equals 1/2. So look at it that way. 3/5 or 1/2? Which one's greater? Jack?
3/5.
That's right. 3/5 is greater. Now, we talked about this before, and this is going to make more sense looking at a number line. But check this out. If you had two number lines, 0 to 1, and remember, guys, in this case, the 1 is going to be 5/5 because we've got a 5 as our denominator, right? So, well, this one, excuse me, on this one, on the bottom one, it's actually not going to be 5/5. It would be, you have to bring, we didn't use the same denominator for the second one. So the second one is actually going to be 2/2, right? Because in this case, we're dividing this one in half, 2 parts, and this one into fifths. So, I'm going to go ahead and draw out the 1/2 right here. And also, I got rid of our 4/8 because I switched it to 1/2, okay? There's where the 1/2 is. Let's use a different color. Let's make this a little bit easier to see. There's where the 1/2 is, right in the middle, right? 3/5 is going to be right here. Is 1 out of 2 closer to 2, or is 3 out of 5 closer to 5? Which one looks like it's further along? What does it look like? Allie? Are you drinking any water? Yeah.
But right here.
It hurts on the outside of your head, not the inside. Do you need an ice pack? Okay, go ahead and ask Miss Michelle. She's in the main office. Shrek, did you have your hand up? Is this one?
2 holes and it 2.
Here, listen to my question again. Is 1 out of 2 closer to the hole, or is 3 out of 5 closer to the hole?
1 out of 2.
You sure about that? Look at the picture. Can you guys see that? Do we need to do a different color? Which one looks closer?
5/5.
Okay, you're just throwing out numbers now. 5/5 is 1 hole. Hurry on. 3/5, right? The 3 is closer to the 5, is it not? Than the 1 is to the 2? Now in this case, or the 4 is to the 8. Would it help you if I did it as 4/8 instead of 1/2? It's the same thing. Look at the picture. Look at how we drew it out. Draw it out if you guys need to draw it out. Draw it out. Remember what I said, when in doubt, draw it out. I drew it as a number line because that's what we're going to be doing. But if you draw it out, you can see which one is further along, right? Now, because in this problem it didn't specify that we needed to have different denominators, let's look at the one that has the same denominator. Is 3/5 greater than 2/5? Which one's greater, 3/5 or 2/5? 3/5. How do you know? Yes, Andrew. That's right. That's something to remember. When you have a like denominator and the numerator is different, the larger numerator will be the bigger fraction, right? Now, typically, let's look back at this one again. If we kept it at 4/8, we could look at it this way. We had a different denominator and a different numerator, but in this case, that denominator made us think of smaller parts, right? You see what I'm saying? Guys, hey, everybody, look at the board. If you're not writing things down on your paper, you should be paying attention. Okay? I already stopped and we did a little break, just like you guys wanted. So, let's focus again, because we still have to do this work. And you guys know this stuff already. Break. Yes, please do. Let's move on to our next one here. Everybody should have these things written down. If you don't, you're only hurting yourselves. I don't go over this because it's fun to do. I go over it to help you guys so that when we do the independent practice section, you guys have something to look back at. So, how much far? Let's take a look at this side here. It says, in 3 to 5, compare fractions and use the number lines to help. Okay. So I know a lot of you guys are at the point where you're comparing fractions without drawing it out. That's fine. But keep in mind, you do need to know how to use these things, okay? In case you do end up seeing them. And so for some of you, it's going to help you understand how they work, how fractions work, right? Okay, so here we have 2/4 and 2/3. Where am I going to mark 2/4 on the top one? We've got 4 parts, right? 1, 2, 3, 4. Where do I mark the 2/4? Jed?
In the middle because it's a half.
That's exactly right. 2/4 does equal 1/2. So it's right in the middle. Now, where am I going to mark 2/3 at the bottom one? Remember, we've got 3 jumps, right? 1, 2, 3. 3 parts, 3 lengths. And the number line. Schmidt.
Second line.
Right here?
Mm-hmm.
That's right. So taking a look at it now, and again, guys, when you draw it out, especially if it's already drawn for you, trust your eyes. Which is the greater fraction, Heston, 2/4 or 2/3? 2/3. That's right. 2/3 is the greater fraction. Okay, what about in this one here? We obviously have 6 parts in this one. 1, 2, 3, 4, 5, 6. And 3 in this one. 1, 2, 3. We know also because of the denominator, right? 6 and 3. Now, we've got 2/6 and 1/3. Where am I going to draw the point for 2/6? Ariana? Right here? And Jed, where am I drawing the point for 1/3?
Right where 2/6 is, and it's equal because they're equivalent.
That's right, they are equivalent. You guys see that? You can see it with your eyes, right? Trust your eyes on this one. They line up. So they are equivalent. Plus, guys, you remember how equivalent fractions work, right? Look at this. 1/3, you can find a common factor, can you not? How can you get from 3 to 6? 3 times what is 6? Ariana? 3 times 2 is 6. That's right. 3 times 2 equals 6. Now, what times 1 would equal 2? Right? What times 1 would equal 2?
2.
That's right. Remember, when you have a common factor, remember that, guys, this is a common factor. You have to do whatever you do to the bottom, you have to do to the top. It's got to be the same, right? So we found a common factor. Here's the other way of looking at this, because we're looking at thirds, right? That means that the bottom number, remember this, guys. If we're looking for equivalent fractions, we 1/3, 2/6. What would be the next one, guys? What's the next one in line? Briggs. You know this. There's a couple patterns we're looking at here. That's right. 3 and 9. So what's the next one? Jed?
4/12.
That's right. 4/12. That's right. What is the next one, Allie? After 4/12. What do you think?
1 around.
We're looking at equivalent fractions. 1/3, 2 6, 3 9, 4 12. What's next? What comes next? See some hands going up. What comes next? You remember? We're looking. Look at the bottom. We're counting by threes on the bottom. We're skip counting by threes. 3, 6, 9, 12. What comes next?
Oh, 15.
15. So then what's going to be our numerator? Look at the pattern on top. 1, 2, 3, 4.
5.
That's right. 5, 15th. And then, of course, we keep going. Next would be what, Andrew? That's right. 6, 18th. Good. And, of course, you see the other pattern here, too, right, guys? You see the other pattern? What's 18 divided by 3? What's 18 divided by 3, Jed?
6.
What's 15 divided by 3?
5.
Yeah. Okay, so look at this one.
And also the
What's 18 divided by 6?
6.
No, 18 divided by 6?
3.
3. What's 15 divided by 5?
3.
What's 12 divided by 4?
3.
What's 9 divided by 3?
3.
What is 6 divided by 2?
3.
What is 3 divided by 1?
3.
Notice the pattern? Anytime you've got something like this, 1/3, you can take that denominator, divide it by the numerator, and then you can tell that these are equivalent. You guys see that? Make sense? Jed.
But the one after 6/18 is 7.
That's right. That's exactly right. Does that make sense, guys? I think you guys get those. I think sometimes it just looks confusing when you see them not in order, but it makes sense. You see the patterns? Thumbs up if you can see the patterns. Good. Good. And you're skip counting, right? You guys can do that. Multiplication. Schmidt, question.
Can I get my name tab?
You don't need it currently. Okay. What about this one? We have 8 parts, right? Because our denominator is 8. Now, we've got a like denominator. Like denominator. Heston, which one's greater?
5.
That's right, 5/8. Because 5/8 would be right here, and 3/8 would be right here. Which one's closer to 8/8? Remember, 1 equals 8/8 in this case. Which one of those is closer to 8/8? Andrew? That's right. This is a lot closer than this one is. So whichever one you have the shortest distance is the one that you want. That's the greater one, right? The greater fraction. Does it make sense, guys? Yeah, thumbs up? Good. Okay, so here's what we're going to do. We are going to work independently on the independent practice section. Skip the back page and go to the homework and practice first. When you're done with those two, then work on this back page right here. Okay? So one more time. Independent practice first. Homework and practice second. I don't know why that circle is right there. And then math practice is problem solving third. Okay? Look at that. Somehow I'm bringing the circles with me. That is not intentional. It was like magic. I don't know. And then it disappeared. Okay. So let's go ahead and get started. We will work probably up until about recess. We'll have recess. We will be doing some lunchroom rules after recess. And then we'll come back and go over this again. Okay? So let's go ahead and get started. So I want everybody back on this page right here.
And by the time he's done, nobody should have blank paper.
That's exactly right. Listen, I'm going to say it again. I say it every time. And we've gone around, okay? Both of us. We can see what you guys have done when it comes up. It is not okay for you guys to wait until I go over it to write answers down, okay? It is okay for you to correct your answers. You got them wrong. Okay? It's also okay to ask questions. Tell me if you don't understand something. to make sure that you're doing that. Now it's all right. I know some of you didn't get a couple things done on the back page, like the Common Core section. That's okay. We're still going to go through. Okay. But I think everybody else got the independent practice and the homework and practice page done. Correct? Thumbs up. Everybody got that one done? Those two done? Yes? Good. Okay, so let's go over it. Let's take a look. In our independent practice section here, it says use the number lines to compare the fractions, and we're going to use our symbols. Greater than, less than, or equal to. Now, what I really recommend on these, because I've seen a couple of you guys make mistakes on it, is to also mark where those fractions fall on the number line, okay? It helps you understand it better. Brewer, go ahead and, let's see, are you boys out? No, Briggs, I think you're okay to go. Okay. So on this one, first, we need to mark 1/4, then 3/4. Which fraction is greater, guys? 1/4 or 3/4?
3/4.
That's right. Remember, when you have a like denominator, your denominator is the same. It means that you can use one number line because you have the same number of parts in the whole, correct? Yes?
Yeah.
And it means that the numerator that's greater indicates to you that the fraction is greater, correct?
Yeah.
Yes, that's because we have, what's this called again? What's it called when the denominators are the same?
Like denominators.
Like denominators, exactly. Okay, let's look at 7. Denominator 6, so we have 6 parts, right? 1, 2, 3, 4, 5, 6. That one didn't much. Let's mark 4, 6, and let's mark 3, 6. Now, first question. What is 3 6 equivalent to?
1/2.
That's right. It's right in the middle. 3 6 equals 1/2. So what's greater? 4 6 or 3 6?
4/6.
That's right. And you can see it with your eyes, right? You can see where it is. That's why I recommend that you guys mark those. What about number 8? We do not have like denominators. We have unlike denominators. We have unlike denominators and unlike numerators. So we have 2 things that are happening here. This one, because it's a 2, means that we have 2 parts in the whole. This one, because it's 4, means we have 4 parts in the whole. Now, let's mark the 1/2. Everybody mark it. Mark the 2/4. You should automatically know something here. What is 2/4 equivalent to?
1/2.
That's right. They line up. 2/4 equals 1/2. So, what should I be putting there, guys?
Equal.
That's right. They're equal. Okay, now what about this one? Again, unlike denominators, but we have like numerators. Like numerators, but unlike denominators. So we have 3 parts here because the denominator is 3. We have 8 here, right? Because the denominator is 8. Which again means that the whole here is 8 out of 8. And the whole here is 3 out of 3, correct? So, which is greater? Let's mark our 1/3. And let's mark 1/8. Which is greater? 1/3 or 1/8?
1/3.
That's right. Because in this case, look how much closer that is to the one than our 1/8. We have 8 whole parts. That means you have 7 more parts to jump before you would actually get to 8/8, right? Whereas in this case, you don't have that far to go. You've only got 2. Okay, so any questions on these? Everybody got these? Jack, question.
Number 8, I didn't see the 2/4, so I did 2/4 greater.
I see, but now it makes sense, right? Good. Talon, question.
It's the same thing as Jack.
But now it makes sense to you? Did you guys mark them? Because if you mark them, you can see they line up. Make sure you're always marking them. Make your lives easier. Schmidt.
I realized it right away. That,
Good.
One
I'm glad to see that.
and 2/4 are equivalent.
That's right, because 2 is what to 4? What's the relationship?
1/2.
That's right. 2 is half of 4. Okay, let's move on to, let's do the homework and practice one first. Now remember guys, in the another look section, this is a section to help you if you need a reminder about how you're going to be doing the work. Right. Okay? So it says Ben has a ½ yard of string. John has a 1/3 yard of string. Who has more string? Well, look, we marked them. Which is greater, a half or a 1/3? Which is greater, 1/2 or 1/3, Jack?
1/3.
That's right. Wait a minute, is it right? It's not right.
1.
That's right. Look at the picture, guys. It's not 1/3, it's 1/2. Look at the picture. Which one, in this case, which one is closer to the whole, to the 1? On the number line, look at it as which one is closer to getting to the end, to the 1. Your 1 whole. If
1/2 is close.
it is, that's right. That's right. You can draw 2 number lines of equal length to compare fractions with different denominators. So the equal length part, guys, that's because they're ending at the same spot, right? That essentially means that our wholes are the same. The length in its entirety is the same. What we've cut them up into is different, right? Because this one has 3, 1, 2, 3, and this one has 2, 1, 2. You see what I mean? But which one of those dots, go ahead, is closer to the end? It would be the 1/2, correct? Can everybody see that one? Now it says mark 0 and 1 on both number lines, which we did. Divide the first number line into 2, which we did, and mark 1/2. Remember guys, always mark the points, okay? Divide the second number line into 3 equal parts and mark 1/3, which we did. 1/2 is farther to the right than 1/3, so 1/2 is greater than 1/3. Guys, in the another look section, they always give you the answer, okay? So you have to read it because it tells you exactly what to expect when you move on. Now, let's look down here. Use the number lines to compare the fractions and use our symbols. Here we go. We have, how many parts do we have here in this first one? How many parts?
8.
And what do we call those denominators?
Like denominators.
That's right. They're the same, so it's like denominators. Now let's mark them. If you have not marked these, mark them right now. Pencils to your paper if you didn't mark these. We have 7/8 and 4/8. We marked them both. Mark them if you didn't do it. Next question is, what is 4/8 equivalent to?
1/2.
That's right. Because half of 8 is what? Half of 8 is what?
1/2.
No. Half of 8 is what? So what's 8 divided by 2?
Half of 4.
8 divided by 2 equals 4. That means half of 8 is 4, correct? Yes. So 4 is half of 8. So you are correct. 4/8 is 1/2. So in this case, which is greater? 7/8 or 4/8?
7/8.
That's right. Why is that? Somebody tell me why. Jack?
It's closer to 1 whole.
That's exactly right. It's closer to 1 whole. Look how far it is. How many spaces do you have to get? Just 1 more. How many more do you have to get when you're at 1/2? How many more would we have to jump? How many more jumps would we have to make?
4.
4. That's right. Now over here we have 6 jumps total, right? 1, 2, 3, 4, 5, 6. To get from 0 to 1. And in this case, the 1 is 6, 6, right? We have like denominators again. Which one is greater? Let's mark our 1, 6. Everybody mark them if you haven't. And let's mark 3, 6. First question. What is 3, 6 equivalent to?
1/2.
That's right. So you can tell by looking at it, but how else do you know? What is the relationship between 3 and 6? Yeah, go ahead. What's the relationship between 3 and 6, Jack?
3 is half of 6.
That's right. 3 is half of 6. Now, which one's greater? 1, 6 or 3, 6? 1, 6 or 3, 6?
3, 6.
Yes, because 3, 6 is closer to the 1 whole. Is it not? Go ahead. Okay, let's look at number 3. We do not have like denominators here. They are different, unlike denominators. We do have like numerators, but does that really mean anything here? Not much, right? Because let's mark them. On the 1/3 line, we're going to mark 1/3. On 1/6, we're going to mark 1/6. This one has 3 parts, right? This one has 6. Which is the greater fraction, 1/3 or 1/6?
1/3.
That's right. Because look at the picture. 1/3 is closer to 1, correct? It's further along. Yes?
Well, I was saying 3, 6. I get my phone.
I'm sorry to hear that. Okay. But if that's what you were waiting to tell me, you should be paying more attention. 1/2 and 4/8. Guys, let's mark this. Mark them. Are they equal?
Yeah.
Because 4/8 is equivalent to 1/2, correct?
Yes.
And you could have definitely looked back up and you would have seen it up here too, right? Because 4 is half of 8. That is correct. Any questions on those right there? 1 through 4. Any questions on 1 through 4? You guys feel pretty good about those? Thumbs up. If you feel good about it. Yeah? Anybody have any questions on those? No question? Okay, thumbs up. Let's move down to those bottom ones here. Compare the fractions, use the number lines to help. Look at that again. Now, we can draw number lines to help. Remember what I said? When in doubt, draw it out. Go ahead and sharpen it. Okay. When in doubt, draw it out. Go ahead and throw that away. But, if you don't need to, that's okay too. But, I just used but again probably too many times in one sentence. When in doubt, draw it out. Yeah. Let's with an eye roll. You okay over there? Saw your eyes roll back in your head. I thought you were rolling your eyes at me. I see how it is. Okay. Okay. 1/4 away. Let's draw them out, guys. I think it's helpful. Let's draw it out. These are going to be the same. We got the same holes. This one, though, for 1/4. How many spaces do I need? How many lengths? How many jumps? Go ahead. Jeff. That's right. Now, ideally, they'd be equal, correct? But we have 4. 1, 2, 3, 4. Now, for the 8, how many spaces do I need? For 1/8. How many spaces do I need? Briggs, you go ahead and sharpen. Somebody tell me how many spaces I need. Tell. I did say that, yeah. I mean, I wouldn't mind seeing it. Well, 1/4, we already drew them out. How many spaces am I drawing for 1/8? How many spaces do I need? The denominator is 8. That's right, 8 of them. That's exactly right. So remember, guys, when that happens, you have to draw 7 lines. So, in this case, 1, 2, 3, 4, 5, 6, 7, 8. Where do I draw the 1/4 on the first line? What? Here, huh? Right here. Would be 1/4, right? Where do I draw 1/8? Where do I draw 1/8, Heston? On that number line. Did you draw these out? Didn't I recommend doing it? Where do I draw the 1/8? Where does it go? Say it again? It goes on the line with 8, right? But which one? This one right here? Is that where it goes? Does that make sense? Should look just like the other number lines, right? So in this case, if you've drawn it out, which one's greater? 1/4 or 1/8? Which one's greater?
1/4.
That's right. Did anybody get anything different on that one? It's okay if you did, but did anybody get one different than that? No? You guys all got that one? Yes? Now what about this one here? First of all, guys, what is 3/6 equivalent to?
1/2.
That's right. So you know what they're really asking you is 1/2 and 3/4, right? Well, which one's greater?
3, 4, 3, 4.
Is it 3/4?
3/4.
3/4? That's right. Now, if you were to draw it out, you would see why. 0 and 1. Okay? Now, in this case, on the top line, we're only dividing it into 2. On the bottom one, though, it's being divided into 4. Okay? Now, the 1/2 would go right there, and 3/4 would go way over here. Yeah, 3/4 is closer to 1 whole than 1/2. Does that make sense? You guys see that one? Thumbs up? Oh, I'm not seeing some thumbs. Does that mean people aren't getting it? And that means you're still getting it. Okay, now let me just ask you this here. What's 4/8 equivalent to?
1/2.
That's right. So which one's greater than? 4/8 or 4/6?
4/6.
4/6? How do you know? Jack, how do you know? That's right. That is true. Because the 4 is closer to the 6 than the 1 is to the 2. Is that not correct? It's correct, isn't it? Now what about 2/3 and 2/4? First of all, what is 2/4 equivalent to?
1/2.
That's right. That's also 1/2. So which is greater, 2/3 or 1/2?
2/3.
Allie, question? Your mouth is? I'm sorry to hear that. Are you drinking water? I don't see any water. You need to drink some water. I'm sorry to hear that. You gotta stop touching it though. Put your hand in there. You'll get germs and stuff. Okay? What do we say here? 2/3? That's right, because the 2 is closer to the 3 than the 1 is to the 2, correct? Because if you were to draw it out, as a number line, you would have, right, here's the 1/2, and here's 2/3. See how it's closer to the whole? Does that make sense, guys? Thumbs up if that makes sense. Yes? Okay. Now, I know that there were some challenges on this page. Let's take a quick look at it. Let's look at this one first. Randy wants to save $39. Highlight, underline, circle the important information. Make sure that your eyes are drawn to what they're asking you and the numbers that they're giving you. The table, it's right here, shows you how much money he's saved. Explain, which means I want a sentence, okay? Not only do I want caps, capitalization, accuracy, punctuation, and spelling, I want to see race, restate, answer, cite, and explain. Restate. You guys have to get in the habit of doing that, okay? Explain how you can use estimation. Remember what estimation means? Who wants to tell me what that means? Jack? That's right, like an educated guess, right? When we're using some of the information that they give you. If he has saved enough money. Let's take a look. First of all, he wants to save $39. In March, he saved 14. In April, he saved 11. In May, he saved 22. What is my operation that I need to use here first? Wilkins. What's that called? Addition. That's correct. Let's do that one first. We're going to get 5 and 2, 25, right? Let's add that. So he saved, over that 3-month period, $47. Does everybody have $47 for that one?
Yes.
Good. Good. If you don't, double check your math. Double check your math if you don't have that. Okay, so he's got $47 total. Now, explain how you can use estimation to decide if he has saved enough money. Who wants to explain to me how you can use estimation here? Grace? Yep, what's your sentence?
Yes, because 22 plus 14 plus 11 equals 47 is the only one to 39.
And that is true. That is correct. The only thing that's missing there is how to use estimation. Right? How can we throw something in about estimation? It's a good sentence, but how can we throw something in? Wilkins?
I wrote Well, Randy has enough money because 22 plus 11 plus 14 plus equals 47, so he has more than me.
He does. You guys both wrote excellent sentences. You're both missing the part about estimation. Did anybody put estimation in theirs? Grace? How could you put it in?
Estimation is guess.
An educated guess, right? Well, so you might be rounding in this case. So what if we said, let's see, Randy needs about, let's write this down. Randy, you guys don't have to. Randy needs about $40. He has saved about $50. So, Randy has saved more than he needs. Does that make sense? We rounded. We're estimating. We said Randy needs about $40. He saved about 50. Does that make sense, guys? Do you see what I'm saying here? You guys have some really good sentences, though. Just make sure you're reading the questions entirely. Because this one asked you for estimation. They wanted you to estimate. Do some rounding. Say about. Remember that word? That's one of our key words when you're estimating. About. Okay. Let's look at this one here. Bless you. Scott ate 2/8, bless you, of a fruit bar and ate 4/8 of a different fruit bar. Can you tell who ate more of the fruit bar? And explain. Bless you. Okay, so we've got 2/8. So this is what we really have. Wow, bless you. Those allergies, man. So we got 2/8, but Anne ate, what's 4/8 equivalent to?
1/2. 1/2.
So Anne actually ate 1/2. Okay, so can you tell who ate more? Somebody give me a sentence, complete sentence, Ian, of who ate more and how you can tell.
Anne ate more fruit ball.
You have to explain though. How do you know? Restate, answer, cite, and explain. So in this case, you're restating, you're going to say, Anne ate more of the fruit bar. We need more though. Because, Schmidt.
Can I say my whole sentence?
Say it.
Anna ate more of the candy bar because.
It's a fruit bar, but that's alright.
I meant, sorry. Yeah, I put candy. I'm gonna put fruit bar.
It's okay, it doesn't matter.
Because 4/8 is more than 2/8.
Because 4/8 is more than 2/8. And that is true. And then you give your evidence there. Jack. Yes, Jack, what's your sentence?
Scott ate more of the fruit bar than Anne because 4/8 is equal to 1/2.
But is 1/2 more than 2/8? Because you just said Scott ate more, didn't you? Are you sure that Scott ate more? Bless you. Bless you. Let's draw them out. And let's use it as 4/8. I know I switched it to 1/2, but let's draw out the fruit bar. They should be exactly the same. The exact same whole, okay? And let's see, we had 8. 1, 2, 3, 4, 5, 6, 7, 8. So both of these are the same whole, the same fruit bar. And in this case, Scott ate 2. And Anne ate 1/2. Who ate more of that fruit bar? Who ate more of that fruit bar? Bruce.
Because my dad doesn't like fruit bar.
Because his dad's name is Scott, you guys get it? But look at the picture, guys. When in doubt, draw it out. Anne ate more. Anne ate more. Good sentences, though. I like your sentences. Test it. Okay. Let's move on. Does that one make sense, guys? Allie,
Can I read my?
what was the sentence you had?
Okay. Eat can't eat more because she ate half of the fruit bar.
That's right. Because she ate half of the fruit bar. And then I would add, and half is greater than 2/8. Right? Aiden.
My dad and Uncle Dave are in this.
Ah, that's the same thing for Briggs over here. Okay, guys, moving on though from the names. Does this one make sense? You guys had some good sentences. Just make sure that you were telling me why. Tell me why. That's what explaining means. And remember, in race, you have to cite your evidence. Tell me why. Explain it. Okay? Matt and Adara have identical pieces of cardboard. Identical means they're the same piece of cardboard for an art project. Matt uses 2/3. Adara uses 2/6 of her piece. Who uses more, Matt or Adara? That's the question, right? Who uses more? Draw 2 number lines to help. Okay, so if you didn't draw 2 number lines here, you already did it wrong. It literally says draw 2 number lines. If you didn't do it, it means it's not complete. So make sure you've drawn 2 number lines in that one. So let's draw that. We'll start with 0 and with 1, because that's the whole, right? First one, we have to divide into 3. Second one, though, we're dividing into 6. Now, Matt had 2/3. This is where 2/3 lands. And Adara uses 2/6. This one's Matt over here. That's Adara. So, who used more? Who used more? Who used more? Jen, who used more? Matt or Adara? Who used more of their cardboard?
Matt.
Matt did. How do you know?
Because 2/3 is greater than 2/6.
That's correct. That is correct. What is 2/6 equivalent to, guys? You should be able to see it right here. What is 2/6 equivalent to, Schmidt?
Okay, I have like a whole bunch of things to say. I'm the one that helped write on this, and I wrote 2 number lines, and I paid attention.
Okay, good, but I'm asking you a question right now that has nothing to do with any of those things.
Okay.
What is 2/6 equivalent to? You should be able to see it right
1/2.
there. Nope, it's not equivalent to 1/2.
1 whole.
Nope. 2/6, guys. Look at the picture. Look at the
2/3.
picture. Not 2/3. The 2/3 is way over here.
1/3.
Look at the picture. You were guessing, but yes, it is 1/3. Because look, guys, they line up. They line up. That would have been equivalent. Bricks.
Obviously, she didn't pay attention.
Well, remember what happened. She was paying attention originally. Then she got an idea in her head. This is what happens to all of you. You put your hands up, your ears closed, because all you're thinking is, these are the things I want to say. Oh, I've got 2. No, 3 things I want to say.
5,000.
And I'm in the background, and I sound like one of those, one of the adults or the teachers in Charlie Brown. Wah, 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 wah. And that's all you guys are hearing, because you're like this. I've got things I want to say. Wah, 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 wah. See what I mean? Okay, let's look at this higher order thinking. Higher order thinking. Some friends shared a pizza. Nicole ate 2/8 of the pizza. Remember, they shared it, guys. It means we're talking about one pizza, doesn't it? One pizza. Ciao.
Who's our neighbor?
Okay. Nicole ate 2/8 of the pizza. Chris ate 1/8 more than Johan. Mike ate 1/8 of the pizza. Johan ate 1/8 more than Mike. Who ate the most pizza? This is a multiple step problem. This is a multiple step problem. Jen.
Chris ate more pizza because Mike ate 1/8 and Johan ate 2/8. So Chris ate 1/8 more than him, so it's 3/8, and that's how Chris ate more.
Okay, good. Let's mark these, guys. If you didn't mark this, guys, you hurt yourselves. Mark it. Let's see. So we've got Mike at 1/8, Nicole at 2/8, Chris ate 1/8 more than Johan. Johan ate 1/8 more than Mike. Well, Mike is at 1/8. So that means that Johan is also at 2/8, correct? And it means that it says Chris ate 1/8 more than Johan. So Chris is now at 3/8. Anybody get anything different on that one? Let's talk about it. Anybody get anything different on that one? What do you guys think? Come on, guys, be honest. So you're telling me every single person got that one right? I see some thumbs. Give me thumbs if you got it right. Allie, question? I know, I'm sorry, but I don't think there's anything I can do for you. But I do want you to stop messing with it. But also, drink some water. You got to get yourself some water, okay? Do you have a bottle? Yeah. Let's see if I have one left. I don't. Okay. I think Miss Paul is getting us some. We'll get you some, okay? Schmidt, question.
Okay, I did get one.
What'd you get?
I got the 3. I didn't put the 3/8.
Didn't put 3/8. Anybody else not put that one? So you're telling me if I walk around right now, every single person got this one right? No, to be honest, guys, tell me.
I didn't mark down, but I didn't do it.
When you mark it, does it make more sense? Jack. That's okay. What did you think? Who did you put? You put Nicole? Because you missed a step, right? You forgot to look at it. It says Chris ate 1/8 more than Johan, and Johan actually ended up eating the same amount as Nicole, correct? That's why I marked them. Always mark them. Through it. Okay, guys, we are not talking about names of people right now. Make sure that when you see those like that you are following every step, because there's a multiple step problem, right? You have to figure out. Always mark them. Brewer, I want you to switch spots with Abigail. We'll do that as soon as we're done with this, okay? Inez has 2 rows of plants. There are 8 plants in each row. Each plant has 3 flowers. How many flowers are there in all? This is a multiple step problem again. Multiple step, Wilkins.
My sentence is Inez has 24 flowers in all.
So Wilkins says that Inez has 24 flowers in all. What do we think, guys? Did you draw it out? 2 rows of plants. Let's make rows. 2 rows of plants. 8 in each row. 8 in each row. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 plants. Each one of those plants has 3 flowers. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. That's getting old, right? There's another way to do this, isn't there? How do we do it? Right? We could skip count too. We could. So we could say here, because we know there are 8 in this row and there are 3 per, we could say 3, 6, 9, 12, 15, 18. What's next, guys?
21.
21. What's next?
24.
So you know there are 24 flowers in that row. But that also means, again, 3, 6, 9, 12, 15, 18, 21, 24. 24 flowers in that row as well. So, what's our next step? What's the operation now? Zoe. 48, because we added these, right? Exactly, you are correct. 48 flowers. It was a multiple step problem, right? 48 flowers. Now, you could have also written it out as an equation, right? You could have said 2 times 8, correct? What happens if we do it this way? 2 times 8 times 3. What do the parentheses mean again? What if I put parentheses? What do I want you to do first, Ariana?
We have to do 2 times 8 first.
Yep, we want to do that first. So what is 2 times 8? Now we can do 16 times 3. Now that looks kind of like a an intimidating number, doesn't it? But we could do it. We could do it. Is it going to come up to this? Is this going to work? Is it going to work? Yes. That's exactly right. So what is 6 times 3? 18. We're going to carry the 1. What's 3 times 1? And plus 1? It works. It works. That's your equation. Make sense? Yes, well.
The wasp was on my leg, and now it's on my back.
Okay, I'll get the wasp. Don't worry about it. I will get it. Does that one make sense, guys? Now that we've seen it. Does it make sense? Yes, thumbs up? It is in the back. You are correct. Guys. It's dead. Guys, go ahead. Okay, guys, I'm going to skip over this Common Core section for now just because we need to move on. If you didn't do it, that's okay. If we do have time later, we'll come back to it. But for now, we're going to leave it as is. Does anybody have any questions about math before we move on for the day?